Okay, so we've reviewed Pythagorean theorem, and now we're going to look at some other properties of right triangles. You've probably heard of trigonometry, and so it's a form of geometry, I guess you'd say, where we use it to find missing sides and missing angles in right triangles in grade 10. And then in grade 11, we learned about using trig for other types of triangles that aren't right triangles, obtuse triangles. And so there's more that we do with trig. We can also talk about trig functions, which are like sine waves in science. If you look at that squiggly sort of cyclic curve, if you graph it, that's actually y equals sine x. In any case, let's start with your right triangles. So it says, put a circle around the label on the opposite side of angle A. So this is what you have to get really good at. So here we're going to look at, so we've got angle A here, and the opposite side does not touch that vertex. So that means it's got to be this side. So put a circle around this. This is the opposite, abbreviated to OPP. Then it says put a triangle around the label on the hypotenuse. Remember, the hypotenuse is opposite the 90. It's the longest side. Put a triangle around that. And then a box around the adjacent side to angle A. So adjacent means it's just touching. So it's forming angle A with the hypotenuse, and we're putting a box around it. So that's adjacent, and this is hypotenuse. Those are the abbreviations we often use. Okay, so then it says the city of Airdrie, Alberta is building a skateboard ramp with an elevation angle of 40 degrees for a new skate park. How long are the support beams represented in the diagram? Okay, so it says what sides are opposite angle A? So name two of them. There's obviously a lot of them because they're all of these vertical lines here. They're opposite A. They are not forming angle A. They're opposite it. So two of them would be, how about DE and FG? But you could do HIBC. It says measure the lengths as accurately as you can. Record your results in the chart. So pause the video, get a ruler out, and measure in metric the lengths of each of those line segments. So the hypotenuse here, AE, then AG, okay, and then choose another hypotenuse. So you could do, let's see, if we did AG, we could do, let's do the whole thing, AC. Well, actually, let's change it to just go in order, AI, okay? So you do the measuring, pause it, and then come back. I'm going to start entering the values. Okay, these are approximate, so they may not be exactly, but they should be very close. Okay, so those are the sides. You can see they are getting, each of them are getting, oh, what happened there? GF. AG, GF. Yeah, I guess that makes sense. Okay, so we are going to now find some ratios. So it says, what is the ratio for opposite side of 40 degrees over the hypotenuse? So the opposite side of 40, well, there's many. So we're going to start with ED. So if we look at ED here, it's 12. And AE is the hypotenuse, is 19. Okay, How about GF? So GF is 25. AG is 39. Okay, what do you notice? Well, if we find the decimal form of these, so now if I go 12 divided by 19, I get, oops, that wasn't 12. 12 divided by 19, I get 0.6. If I go 25 divided by 39, I get 0.6 as well. To two decimal places, they're a little bit different. So 0.63, 0.64. They are close in value. Ideally, they would be exactly the same if we could measure more accurately. Okay, so the sine ratio, so we'll start on that now. So SINE, we abbreviate it to SIN, but math is not a sin, so we still say the word sine, even though we don't put the E in there. Not sin E, we say sine E. So the ratio of the length of the opposite side to the length of the hypotenuse. That's what the sine ratio is. So this is the sine ratio of 40 degrees. Okay. So you can use a scientific calculator to determine the sine of an acute angle in a right triangle. What is the sine of 40? So if you get out your calculator, you just have to make sure your mode, your calculator is in degree mode. So if you have a graphing calculator, go to mode key, look at degree. If you have a scientific calculator, it should have a little D or DEG on the screen. Okay, and so now we're going to punch in sine of 40, close the bracket, and we get 0.64. So as you can see, very close. The calculator has all these trig ratios stored in there. They're ratios. They're not measurements. We don't say that that value has any sort of millimeters, centimeter, that kind of thing, because we are dividing millimeters by millimeters. So there's no units anymore. It's a ratio of sides. Okay, it says draw two different right triangles with a 25-degree angle, measure the sides, compare the values. Okay, so we're not going to measure that. Maybe in class you'll have some protractors and you can do that. What you will find is the same thing, that it doesn't matter how big the triangle is. If it's a right triangle and you're looking at the 25 degrees angle in both, so basically it'll be two triangles like that. This is 25. Then the ratio of the sides will be the same. Okay. So what conclusion can you make based on your results? That in a right triangle, it has to be a right triangle, the sine ratio, so the sine of an angle is not SIGN, it's SINE. So it's always opposite over hypotenuse. Okay. Now, they do a little tip here. If you're using a scientific calculator, it doesn't show anything on the screen except numbers. So it wouldn't, when you press sine, you don't see SIN on the screen. Then you actually have to put the angle in first and then press sine. So try that out if you're having difficulties. Okay, then we're going to use it here to find missing sides. So a lot of trig is application questions. So Lois is cleaning the rain gutters around a roof. At what height does her ladder touch the building? Round to the nearest one decimal place. So we want to figure out what height this is above the ground. So we know it's a 10-foot ladder. We're told that it's 74 degrees that the ladder forms. Oftentimes on a ladder, they'll tell you what angle is optimal for safety reasons. And so we know that sine of 74 is opposite side over hypotenuse. Well, the opposite side is what we're trying to figure out. The hypotenuse is 10. So this is where you have to solve for that unknown by multiplying by the denominator by 10 on both sides, so there and there. And so in your calculator, actually, I would multiply it by, I would actually put the 10 in front in this one. So 10 times sine of 74, and I wouldn't put units yet. So in my calculator, I go 10 times sine of 74. In a graphing calculator, you don't even have to put times. It's understood. Okay, 9.61. So if you put 10 sine 74, you'll get the same thing. If you have a scientific calculator, you're going to have to put the 74 first if you can't see the word sine when you press that button. And then you would press sine, okay? And then you would multiply, take that answer and multiply by 10. So you would get, I can't do it that way in this calculator, but you basically get the value of sine 74 and then multiply by 10 to get 9.6. Okay. Next one, we've got a communications tower. It's 20 meters tall. For extra support, cables must be attached. How much cable is needed? So basically, we need to figure out what this value is and double it because it's the same on both sides. So this is a 90-degree triangle. You can see it was labeled in there, but it's in both. And so now we want to find the hypotenuse. So we know the opposite. It's 20. But now our hypotenuse, they're calling C. This one's a little bit harder in that it's in the denominator. So now we have to multiply both sides by C to get rid of the C there. So you can see C times sine 60 will equal 20. And then you have to divide by sine 60 of both sides. So it's going to be 20 divided by sine 60. You don't actually have to show this step. You can go right to this step. So remember back up in the last one, we multiplied the sine ratio by 10. Now we're dividing 20 by the sine ratio. So when you're looking for where your unknown is in the denominator, then we divide. Okay, two D's there. So denominator, divide. Numerator, we multiply. Okay, so the unknown's in the numerator. Oops, numerator. So we end up multiplying. So NM DD. All right, so in your calculator, you go 20 divided by sine of 60. Close the brackets. So 23.1. Doesn't say what to round to. We'll go to the nearest 10. But 23.1. Always, if it's the hypotenuse, should be, sorry. So that is C. So now we need to multiply that by 2. So in your calculator, just leave it there. Don't round it. Multiply by 2. Now it would be 46.2 because there's two sides to it, right? Okay, so that's how much cable is needed for that one. So if your unknown's in the denominator, you divide. If your unknown's in the numerator, you multiply. Just remember it. And you're always dividing by the sine ratio or multiplying by the sine ratio or whatever trig ratio, because there's more than one. Okay, so that's the sine ratio.